Hacktoberfest is open to everyone in a global community. Whether you're a developer, a student learning to code, event host, a company of any size, you can help drive growth of open source and make positive contributions to an ever-growing community. All backgrounds and skill levels are encouraged to compete in the challenge. Here's the thing, it does not necessarily have to be coding. You can send in pull requests that update documentation or fix a few grammatical or spelling mistakes. You can contribute to any open source projects hosted on GitHub or GitLab. Log into your GitHub and check out issues labeled Hacktoberfest. We have guidelines that you should follow in order for you to contribute to Hacktoberfest. Guidelines. You can sign up anytime between October 1st and October 31st. Just be sure to sign up on the official Hacktoberfest website for your pull request to count. The pull request must contain commits you made yourself. If a maintainer reports your pull request as spam, it will not be counted towards your participation in Hacktoberfest. A pull request is considered approved once it has an overall approving review from the maintainers or has been merged by the maintainers, or you receive the Hacktoberfest accepted label. Once you've made 4 pull requests, you might have to wait for 14 days for them to be reviewed and approved by the Hacktoberfest team. If done, you're eligible to earn a swag or plant a tree. Next. That is pretty much the introduction for Hacktoberfest. Happy hacking, and Aditya will take over from here and he'll introduce you to TechCast and what you'll be doing for the rest of the event now. Thank you.
Right, so thank you for that amazing introduction to Hacktoberfest, Vijay. So hey everyone, I'm Aditya, and so if you've been at VIT-AP for a while now, you know that the open source community has their very own series. We call it TechCast. In TechCast, we invite speakers that are a part of the global open source community to give a session on present-day technology. We delve into how open source software impacts the world around us and what's being done in the real world out there. So last year, we had Thomas Wolfe on TechCast. Professor Thomas Wolfe was a great start to the series. Being the lead researcher at Hugging Face, he worked with real-life use cases of open source software. Hugging Face is a company that works with natural language processing. It creates transformers which are built by open source, which are built on open source and can be used by the world. And more recently, we had another TechCast. This time we had Manaswini Das for the event. Manaswini Das is currently a software engineer at Red Hat. She's extremely driven towards the concept of open source technology, participating in various different open source initiatives such as Google Codin, Girl Scouts Summer of Code, and Red Hat Open Source Contest. So she brought in a topic that introduced all of us to what technology can achieve and where it is limited. With the session being held on REST, GraphQL, and gRPC technology, she managed to have the event be really interactive. It was done with real-life use cases, and she cracked down on some myths that developers may have had regarding tech. So, that was a history of TechCast, and this time we're also doing it alongside Hacktoberfest. We're really lucky to have an amazing crew to work with us this year. And proceeding forward, Bhargavi will be talking about what we have in store for you today. Stay tuned.
Thank you so much, Aditya, for the brief overview of TechCast. And today, for the 3rd episode of TechCast, we have with us Giuseppe Bonocore. He's a principal solution architect at Red Hat, and he has been responsible for designing innovative software architectures based around various open source technologies. And he's also involved in cloud native development, and he has also worked with microservices architectures. And today he's going to be giving us a presentation on the topic DevOps and microservices, an overview. And moving forward, after much deliberation with the speaker, we have picked up a couple of repositories that you can contribute to as a start to Hacktoberfest. So the link that is present on this slide contains a set of repositories that you can start contributing to, especially in the context of DevOps. And we've also set up a couple of repositories from OSC that you can start contributing to. We'll be talking more about that after we get done with the quiz. So after the speaker session, we have a quiz that you can attend. And it's going to be a fun quiz. We'll be sending out certificates to the winners. So, and after that, we'll be talking about all the repositories that we've set up. So make sure you stick around till the end. And if you have any questions regarding the presentation or regarding any events that OSC conducts, make sure you head over to our Discord server. and people there would be more than happy to answer all your questions. And all these links will be updated in the comment section right now. And yeah, without any further ado, let's welcome Mr. Giuseppe Bonocore onto the stage to give us a presentation about DevOps and microservices.
Hello, everybody. Can you hear me?
Yes, sir. You're already audible.
Good morning, and thank you for having me here. So thank you for this introduction. I'm gonna share my screen so we can quickly go into the main topic of this presentation about DevOps and microservices. Okay, I'm sharing. Please confirm, do you see my screen?
Yes, sir.
Okay, perfect. So, hello everybody again. The title of this presentation is DevOps and microservices. We are gonna give an overview. The idea is that everybody can have some good ideas about what DevOps is and microservices, where they play their role into the whole DevOps story. That is supposed to be an overview, so I hope to give you a lot of pointers into things that could be interesting to have a deep dive further. And if you need any further information or any pointer on more detailed topics, please don't hesitate to reach me. Here you can find all my contacts, so no problem with that. I'm gonna transition to next slide. Do you see the next slide? Okay. So who am I? My name is Giuseppe Bonocore. I am a principal solution architect at Red Hat, meaning that my day-by-day job is basically working with customers. I mainly look customers into banking area, and I work with them explaining topics like, as in this presentation, DevOps and adoption of microservices and cloud-native technologies. I live and work in Milan, Italy, and I'm passionate about open source topics since more or less 20 years. My most important topics, the most important topics on my CV, so the things I do the most in my job are Java, programming, Linux, of course. My desktop sharing has been slow lately, so I want to be sure that everybody is in the right slide. Do you see my slide? Why microservices?
Yes, sir. Yes,
okay, perfect. Perfect. Thank you. So why microservices? Why it's relevant to do microservices? Why everybody is talking about cloud native and microservices? Because basically the idea of breaking things down into smaller pieces, and we are talking about applications like in the topic of microservices, but this is also true for other things like organization, teams, and bigger IT systems. Breaking all those things down into smaller pieces, it's a way to enable greater parallelization and autonomy, meaning that each team working on a smaller piece like a microservice can focus better, and more importantly, can reduce the time to value. What is time to value? Time to value is a broader definition. We can say that basically time to value is the time that is elapsed between when you have an idea or when you have a feature to implement and when such feature, such idea can go into production, meaning that somebody can use it. So breaking things down into smaller pieces, like in the microservices idea, it's a great way to shorten this cycle. And we will see that this is also one core idea of the agile methodology. So basically, when you have an idea, when you have a bug to fix, when you have a feature to implement, being able to do this in a smaller time and to receive feedback in a quick way from your final customer, from your audience, so reducing time to value. That's all this is about. One of the first books in which this idea of DevOps has been traded is called the Phoenix Project. If you haven't heard about this book, I strongly advise you to read this book. Is cheap. It's available on all the major book resellers, and it's very nice reading. It's a novel, so it's not a technical book in the strict sense. And it's the story of this guy that is challenged with basically modernizing an old and stratified IT infrastructure. And the goal of this guy and this whole organization, which is described in this novel, is to reach this goal of making 10 deploys per day. Basically, this is one of the core ideas. So 10 deploys per day, it may not seem to be a lot. In many organizations I work with, and in many big organizations, it's quite a huge target, because many of the organizations, I'm talking about banks, but this is true for public sector, this is true for telcos, this is true for all the big organizations. They often, for some critical projects, they are unable to do one deploy per day. They are unable to do even one deploy per month, because the process of releasing software into production is so complex and may have so many downsides that it's often overlooked. You have to do a lot of authorizational steps in order to do into a deploy, and it's not safer, and you will end up with outages and stuff like that. So many big organizations used to be scared of doing deploys into production. So the whole idea of DevOps and the whole idea described in this book, which I advise you to have a look at, is to make deploys easier so that you can do a lot of deploys also per day. You can see a lot of value because your ideas, your bug fix, your new features will go into production quickly. And ultimately, you will have more value into what you do. So we will see that this book is about DevOps, and microservices play a crucial role into having a lot of deploys into production. Brief history of microservices. So how we went into what is called microservice. So starting from the right, the microservice was defined into a famous paper from Tautwerk and Martin Fowler, which is one of the architects behind the microservices concept. And the definition is basically happened into 2014. This is, I think, the first article that was mentioning what a microservice is, and we will see a bit more about that. But to arrive into 2014 with the idea and the definition of what a microservice is by Martin Fowler into this Tautwerk article and paper, there were a lot of intermediate steps. I'm not gonna mention everything, but some of the histories of microservices will say that in 1999 there was one concept that we will see is critical to microservice, which is continuous integration, which was introduced into a software development practice with was called at the time XP, which means extreme programming. So concept behind microservices, it has a long time. You know that behind the concept of microservice there is this technology which is called container. And as an example, one of the first releases of container technologies, which is Docker, it was launched in 2013. But concepts behind the container technologies, they were even older because they were released into the Linux technologies many years ago. So we will see that there are a lot of steps. You will see the release of Netflix into the AWS. There are a lot of steps historically that basically brings us to the definition of microservices. What a microservice is, so I have this slide which I've titled microservices recipes, as in the food recipes, of course. So what are the ingredients that makes a great microservice, the things that you have to consider if you are writing a microservice. So a microservice application is supposed to be immutable and externally configurable. What this means, basically, it means that once you have your feature set, you have your code which is complete, you are supposed to have this code into a form, into a shape that is not manually editable. So you are supposed to compose your code into something which is immutable. Why is that? Because if you have your code, your artifacts, into something that cannot be basically changed, you are sure that your code will behave in the same way being on your local developer machine or into a production server. So basically you will have less bugs, you will have that your code is more stable. And in order to do that, you will have that your code should take configuration from an external source. Docker and Kubernetes, they offer some way to do that, but there are some easier ways like environment variables and stuff like that. This is because, of course, as well as your application is immutable, you will end up still having something that they have to change from environment to environment, like pointers to external systems, like databases or other configurations. So of course, your application should be as immutable as it can be. So everything should be behaving in the same way, regardless of the environment you are running into. But of course, something needs to be changed. And so the configuration should not be embedded into the code, but should be changed externally, like as I said, in many different ways, like, I don't know, environment variables or other external things. So this is another important ingredient of microservices. One more, microservices should be stateless and horizontally scalable. What's that? Stateless refers to the fact that each microservice application should not preserve its state, so the data that is using, into the working memory. So the state of the data should be external to the microservice application. This is a way to ensure that a request coming from a user can be served by any instance of your microservice application. And a common use case is that the following request from the same user can be served by another instance, and the user, all of this is transparent by the user. This is because the data used by the user is not residing, is not living within the microservice itself, but is living externally. And this also has a very interesting side effect, which is that if your microservice, if the application that you are writing doesn't store the state in itself, it will be horizontally scalable, meaning that if you will end up having more requests, you can just add another instance of your microservice and everything will work, because there is no data to be copied from one instance to the another, but you can flexibly, elastically add more instances and destroy instances following the amount of load, the amount of requests that your application is getting, which is very cool and is the way the cloud service that everybody is using works. They work because they are horizontally scalable, they are stateless, so it's easy to follow the amount of requests changing over time. Another important ingredient into the microservice recipe is that each microservice should be decoupled and independently deployable. This is because when you have a big application and you start splitting the features of this application into different microservices that are serving a bigger use case, a bigger application, each of that should be independent. The reason why we stress a lot about the independently deployable and decoupled from the other is that if you want to fix a bug or implement a new feature into a small piece of your broader application, so into just one microservice of the tens or hundreds of microservices that compose your application, you can do it changing only that small piece. So if you write your application, design your application in this way, you will be sure that if you make a mistake into one small microservice, the whole application will still continue to operate as a whole. So you will just have a degradation of the service, but your service will not be down. And another important thing is that you can release more often, because if every deployment, if everything that you have to do to touch into your application is gonna impact just one small piece, this means that basically you can do that while being into production. You don't have to shut down your service completely, but you can, while your user are still using the application, you can change one small bit without impacting the whole application functionality. A common example of this is the Netflix platform. I suppose everybody is familiar with Netflix and with video streaming services. the Netflix platform has different microservices implementing different features. A common example is the suggestion microservice that when you are seeing a movie, can provide suggestions to other movies that can be related or can be interesting to you. So if you think to implement an application like that, having all the features embedded, if you have to change something into the suggestion engine, you will need to redeploy the whole application and maybe you will have some downtime. And if you have a bug into your suggestion application, maybe everything will be slow. But if you think about your application as a microservice application, you will have a dedicated microservice only for the suggestion engine. And if something bad happens, or if you need to release a new feature for your suggestion engine, you can do it without impacting the rest of the platform. So many users will not even understand that there is a problem, and they will just go with streaming without having that small piece available. It's not a problem. Another important ingredient of microservice, or how to write a microservice, is that each microservice should own its own data. We talked about the fact that each microservice should be stateless, so the data should be stored externally. But even with data stored externally, each piece of your application, each microservice, should own its own data. Meaning that if we refer to the previous example of the suggestion service into a video streaming application, the database or the other data sources and data storage that such service should use are property of that microservice. No other microservice can access and edit the data directly. If I need to add a new movie into the suggestion engine, I would use the API and the functionalities provided by the microservice itself. I cannot access directly to the data. So each microservice should own its own data, which brings us to the next point, which is that each microservice composing our bigger application should represent what is called a business domain. This is a bigger topic. We don't have much time to dedicate to this. It's related to what is called domain-driven design, which is basically a way to model the objects that should be into our application. But basically, each microservice should model its own business domain and should be responsible for its own business domain. So if you have a bigger design of your application and you want to understand where to split the responsibilities between each microservice, a good way is to understand what the business domain is. In our example, the business domain of our recommendation engine will have some objects that are proper to the recommendation engine, like a movie, the set of related movies, the relations between such movies, and so on. So basically, each microservice should have a vision of its own world and should own that vision in terms of objects, that models, and that store. And last but not least, a very important thing that is often overlooked around the microservices is that microservice should be technology independent. When you have a big application which is composed by many microservices, each microservice should interact with the other pieces of the application using APIs, and those should be standard APIs like REST APIs operating over JSON objects and things like that. In this way, each particular piece of your application can be implemented with the technology which is more relevant for that particular piece. A common example of this is that if you have a bigger application, you may have some microservices or some applications that are implementing the front end, and such microservice, such application may be written in JavaScript, maybe using Node.js, using static resources in order to build web front ends. But you may have some transactional backends which are written into Java in order to implement transactionality and access to the database. And such different components, they just need to understand each other using a standard API like REST. So it's very easy to make everything interoperable, and you can use the right tool for the right thing to do. Another example is that if you will have a microservice operating over big data and data sciences thing, it's implemented in Python or using some specific TensorFlow library or whatever it is. But it fits into the bigger architecture because it talks with the rest of the architecture by using standard API. So the long story short is that each microservice can be implemented using the best technology for that microservice, and this is a basic ingredient of microservices. Everything can be implemented using the technology that each team chooses the best, provided that then it provides standard APIs for the other microservices to use. There is a very interesting topic about microservice, which will bring us into the whole DevOps discussion. And there is this famous article, which is linked in this slide, which say that you must be this tall in order to do microservices. This is referring, to the roller coaster, where you have to be this big enough in order to ride the roller coaster. And this analogy is basically the same for microservices. So microservice is not for everybody. In order to do microservices, there are some prerequisites that you have to do, because microservices is hard. Microservices is just an implementation of, if you want to, distributed computing. So there are a lot of challenges in terms of network latencies, in terms of where to store the data, how to store the data. We have seen some of those topics, but in practice is very complex, especially for big applications. So in order to go into microservices and to have the biggest advantage of microservices, which we have seen, is time to value. So being able to do a lot of deploys and to be faster into production. But in order to achieve all of this, there are all those prerequisites. This is a list that I've provided. There is this interesting article that you can see by Martin Fowler, which as I said, is one of the most important architects behind the microservices concept. And in this article, he's talking about what are the prerequisites of microservices. I selected 4, which I think are very relevant to our speech. So the first of such prerequisite is the DevOps, sorry, which of course is one core topic of our presentation. And there is an important question here, which is who is on the pager if something goes wrong, if there is an application outage? Because in traditional environments, you will have that there are siloed, very different departments doing development, operations, securities, data management, and whatever is needed. And if there is a production outage, is often the responsibility of just one of those departments. DevOps is a way to shift this paradigm, and it's everybody's responsibility if there is an outage, and everybody is responsible for the whole functioning of the application. So this is one of the core concepts of DevOps. But let's see a bit better what DevOps is. So of course you can have a look at the Wikipedia article that is giving some more details, but basically DevOps is a set of practice that combines at least the software development and the IT operations. So basically this is admin way of doing things. It aims to shorten the system development lifecycle, and this is a goal which is shared with the microservices goal, as you can see. And another goal is to provide continuous delivery. So to have a release which is basically automated and which is basically shorter, and there is a defined path from development to production, and with an higher software quality. So those are the goals of DevOps, and DevOps implements such goals with a set of practice. But it's important also to say that DevOps is complementary with agile software development, which is basically another way, another set of concepts for development software. And several very different DevOps aspects came from the agile methodology. Agile methodology, it's way older than DevOps. It's started in 2001 after Waterfall, and you can see here a piece of the Agile manifesto. But basically, the Agile methodology, it's a methodology which put a lot of stress into individual and interactions over having structural process and tools, into working software over having like more complex things like comprehensive documentation or suite of tests, into having collaboration with customer. This is very important. So the customer is part of the software development lifecycle instead of having a negotiation of a contract. So having everything basically defined upfront before starting with software development. With the Agile, this paradigm change, you will have the customer which is part of the team, and the development process is an iterative process where the customer can give his feedback very, very shortly and a lot of time basically during this process. And another important, very important point of the Agile manifesto, of the Agile software development is responding to change. So instead of trying to have a very detailed plan comprehensive over everything that can happen, with the Agile methodology, and DevOps follow this principle too, you should be ready to respond to change. So this is very, very important. But there is a lot of confusion over the market about what is DevOps, because many of the colleagues I work with, of the customers I have, they just think that doing a lot of deploys or having Jenkins or having Kubernetes or avoiding to do documentation at all, it's a way to do DevOps. Of course, this is wrong, because DevOps is both a collection of tools. So both the tools we have mentioned, like Jenkins, like Kubernetes, like Ansible, all the tools that you will find around are very important. But DevOps is also a philosophy. So you will have to take pieces from the Agile methodology. There are a lot of other pieces around what DevOps is. It puts a lot of stress over cooperation between developers and operations. So it is a philosophy, and it is also a collection of tools supporting such philosophy. So committing to the user of the tools like Jenkins, like the other tools, enables you to adopt better this philosophy. And I do have this picture, which I think is very representative. Basically, a common life cycle of software development is that you will have this wall between the developer and the operation, and the developer will just throw out of this wall, maybe on Friday night, a piece of code, and then it's up to the operation make this piece of code working into production. This is, of course, not the best way, but it used to be a way to develop. So everybody having different goal into the software development, and the developer having the goal of providing more software, and the operation having the goal of being into production and having uptime and stuff like that. So this is not a very productive way. DevOps aims to break such wall between developers and operations, and having everybody working together for the success of the software piece, for the production service to be up and running. DevOps in a nutshell. So how to do DevOps, if you want. It's of course, as you can imagine, a big topic. We could do, like, I don't know, 1 month about DevOps, talking about DevOps, but I want to have this very short point that can help you understand what is DevOps in a nutshell. So an important topic is that you will have small teams that should be cross-department. So you will have a team working over a piece of software, which usually is one or more microservices, and this team should include people like developers, architects, people from operation, may include DBAs, so database administration, may include expert of user interfaces like UX designer and things like that. At the very beginning of DevOps, there was this way of defining these small teams, which is the 2 pizzas team, that basically say that you should have a team which is small enough that can be fed by 2 pizzas. This is usually referring to teams of 6 to 10 people. This is more or less. It is believed that having smaller teams, it's more efficient because you will have less overhead into communication. So everybody knows each other, and it's better from a communication point of view. So you will lose less time into communication. Each of those teams should be product-oriented and production-oriented. So everybody is responsible for the product running into production. Of course, there will be support dynamics. You will have people on call and stuff like that, using turn and things like that. But it's important that everybody is committed for the working software. So the goal of the team should be unified. It's not like the operation has the goal of being uptime and the developer has the goal of implementing everything in time, but everybody has the goal that the product is working, that the customer is happy. So this is very important. And there is this catchphrase, which is you ship it, you run it. If everybody is participating into building the software, everybody is also participating into having the software working properly into production. And of course, as we said, supporting technology is important. We are gonna be back on this topic, but basically it's important to have a self-service environment. So if each team need a particular piece of infrastructure, like a virtual machine, a server, a network system, or whatever it is, or a database. It should be able to create this piece of software in a self-service way. So basically having an interface, ordering what they need, and waiting for this piece to be available. For this reason, DevOps, it works very well into cloud environment, where you can easily have an administration interface and you can provide a database, a server, a virtual machine, whatever you need by yourself. You doesn't need to ask anybody else to do that for you, or to file a ticket, or whatever it is. You will have everything on a self-service value. CI/CD, so having pipelines for continuous integration and continuous development of code, so releasing continuously, constantly, and having also an elastic infrastructure, meaning that if you will need to scale your infrastructure to add more server, to delete some server, it should be easy. You should not, it's very hard to do DevOps if you have to fiddle with hardware infrastructure, putting more pieces into a data center, stuff like that. You will need an infrastructure that follows what you need over time. Back to our list of you must be this tool. So we talked a bit about DevOps. Of course, there is more to say, but I hope you got the core ideas around DevOps. We were talking about self-service, on-demand, elastic infrastructure as code. Why is this relevant, and what are some technologies that help us to have a self-service, on-demand, and elastic infrastructure? And there is this term which is infrastructure as code, so infrastructure to be as easy to provide as it was source code, so it's declarative. There is this important question to answer, which is how many days or weeks or maybe months you will need to have a new virtual machine. This may seem to be like an exaggeration as of today, because we are used to have cloud environments and to ask for a new virtual machine in a matter of minutes or seconds. But in many big customers, this is not the truth. You will have to wait for a machine to be bought, like an hardware machine, to be put into a data center, to have storage and network and whatever it is. So it's important to face this kind of challenges and to have a shorter time to provision what you will need for running your code. And with this regard, I want to quickly introduce the concept of container. We have been used to the concept of virtual machine, so basically having more machine sharing the same hardware through the usage of an hypervisor. The containerized model is just a newer version of the virtual machine model, but it's more efficient. It's more efficient because you will not have like multiple server, multiple version of your operating system like you see on the left part of the slide. So basically each virtual machine bringing its own guest operating system. With the containerized model, you will end up having most of the benefit of virtual machines, like having isolation, each app owning its own machine and owning its own resources, stuff like that. But you will not have like a full big machine with its own operating system and dependency. You will end up sharing pieces of one old operating system. This is what containerized model is all about. Each app just have the pieces that the app needs, but it doesn't need to have a whole operating system replicated. And for this reason, it's easier, it's thinner, it's lighter, it's a better way, it's quicker to provision and similar things. So if you want to have an analogy, the virtual machine is similar to an old ship. So in order to provide and to build it, you will have to manually bring your loads into the ship and arrange it in a good way. And this is not different from what a virtual machine usually is. You will have to provision a new virtual machine and to install things manually and to fiddle around with configuration and similar things. Containers is born to be like an industrialized version of this. So everything is standard, and you will have tools for manipulating things, and putting the load inside the ship is an automated thing. There are very known good practices to do that. So basically, it's a different way to arrange your application into servers. With virtual machine, it's a more manual thing. It's less automated, it's less standardized. With container, is very much automated and standardized and easier, and it becomes commodity. You can easily move an application, so a container, in the case of this image, from one ship to another ship in an easier way. There are no manual tasks to do that. Managing container can be challenging because, of course, splitting one big thing like a virtual machine into smaller things like container means having an increasing number of moving parts. You will end up having interdependencies between the different containers. In the way you manage your infrastructure change, because with virtual machine, as an example, you will have like an IP address, a network address to the whole machine. If you start splitting such machine into a number of containers, each of those containers will have its own network port, network address, and stuff like that. So you will need some infrastructure that is able to manage this kind of heavily distributed computing. And this is the reason why a software like Kubernetes came to life and it's so popular, because software like Kubernetes are doing what is called orchestrating containers. So basically they take care of all the aspects like placing the workload, so identifying the right server where to place the right container, also taking into account like the load of each server, the number of requests it's serving and stuff like that. It will provide infrastructure service. I was mentioning the previous example network, so Kubernetes is taking care of the network address to provide into each container and how to make each container talk to each other. But this is also true for other resources like, I don't know, storage, like the amount of CPU to be provided to each container, the amount of memory and stuff like that. And another interesting thing is that Kubernetes as of today, even if there are other orchestration technologies as of today, Kubernetes is a standard way. Everybody is using Kubernetes. The major cloud providers are providing Kubernetes into cloud, and there are many distributions for running Kubernetes into your own data center. So it's a standard. If you make an application which is compatible with Kubernetes, it's very likely to work on many different distributions of Kubernetes. For this reason, it has been defined as the operating system of the cloud. You know, with Linux, we used to have this kind of revolution in which if you build an application which is Linux compliant, like a Java running application, it's very easy to move this application between different Linux distributions. It's the same with Kubernetes. So basically, it's kind of an operating system. It's taking care of infrastructural things like network and storage and stuff like that. And it's a standard. So it's like an operating system. If you do something which is like an application or a set of microservices and applications working on Kubernetes, it can be easily moved between different Kubernetes distributions on different cloud providers or even on-prem. This brings us to the next point, which is automation. And there is this very important concept that I want to mention. I'm not going to mention any specific automation software or library here, but there is this important concept which I think is very relevant, which is Phoenix versus Snowflake. It's related to a lot of things that we are discussed, especially in the microservices world. So basically, in the enterprise world, so when you are dealing with big customers with a lot of application, the servers and the application look like snowflakes. So every server, every application is a bit different from the other. This is because you release a server into production, and then there is a production outage, and so you will need to do some manual changes on such server. And then maybe one server needs to be updated because the application that is running on this server requires an higher version of a component like a Java virtual machine, stuff like that. And then you will end up having to configure another server because there is a need in terms of performance. So you have to change a particular parameter on that server. At the end of the day, you will end up having a data center, having a lot of applications which are different from each other, like snowflakes. And the bad things with snowflakes is that if you lose one of such snowflake, it's very different to remember how it was made because it wasn't automated. You will end up building your snowflakes, making manual change over manual change, and maybe not documenting well things and not scripting things. So you will end up having everything different. And if you have an outage or if you simply need to scale an application, it becomes hard because you have to understand how your snowflakes is made and make another similar one or another the same. So it's very difficult. You should avoid having a snowflake application. Every application should be the same. And the metaphor here is that the Phoenix. because it is mentioned by Martin Fowler, and it's very important because Phoenix is basically this animal that can be bring up to the life from its own ashes. And it's an important concept because if you have a server or a microservice which is brought down by a production outage or even an hardware fault or whatever it is, you should be able to bring it back to life with no effort. And how you do that? You do that by automation. So you should avoid to manually change everything and to make your application into a snowflakes. But everything you change, it should be script using something like Puppet, Ansible, Chef, or whatever library you like. Terraform is doing something too. So basically, when you need to do a particular change on an application, even if it's running into production, everything should be fixed into an automation script and should be versioned. So if you have something going wrong into production, or you simply need to have another copy of your application, you will simply need to run again the same set of Ansible scripts or Bash scripts or Puppet or whatever you like, and everything is up and running with no manual steps. So this is very important. Avoid to having everything different like a snowflakes, but think about your application, your microservice, as they were ready to be rising from the ashes, to be rising from your code. And this is also the concept behind the infrastructure as code. So having everything declared into a set of scripts that can be run how many times you want. Okay, the last point of our prerequisite for doing microservices is CI/CD. Everybody's talking about CI/CD. You will find a lot of resources around Jenkins. There are other implementations which are interesting right now, like Tekton. So basically, all such software that take care of building a pipeline. So basically, having a set of steps that your application should undergo in order to go into production. But I want to give to you this interesting phrase from Jez Humble, which an important author into the DevOps movement and microservice and agile. And I want to say that the job of that deployment pipeline is to prove that your release candidate is undeployable. What does that mean? It means that a pipeline should have a lot of automated tests and other kind of tests in order to understand if the software you are going to release to production is ready for production or not. And if the software is ready for production, you are supposed to deploy it into production, so as fast as you can. And this is related to the whole goal of microservice and DevOps, which is reduce time to value. So you should have a pipeline, which is a set of steps that your software undergoes, like building, unit testing, security testing, and whatever you like. And this pipeline should be as complete as guaranteeing that your software can go into production. So every time something goes wrong into production and you find a bug that could have been found before going to production, you are supposed to change, to modify your pipeline in order to add more tests and to get this kind of bugs in future releases. In this way, you will evolve your pipeline and you will have something that is stronger and that will catch any bug that is possible to catch before going into production. If you do it this way, you can trust your pipeline and you can release as many times as you want, because you are guaranteed that there are a set of known bugs and performance regression and things like that that can be catched by your pipeline. And if your pipeline goes green, so basically everything is working, you can trust that the release is safe for production. Having such a piece of code, having such a piece of infrastructure, it's a good way to ensure that you can release safely and you can release often into production. Okay, but one of the topic of this speech today is also open source. So how does open source fits into the broader picture that we are running? We talked about DevOps, we talked about microservices, we are talking about different technologies like continuous integration, continuous development, and stuff like that. But what is the role of open source into all of that? Well, actually, DevOps is in love with open source. This is because many of the practice of the DevOps, like favoring open exchange between different members of the team belonging to different skill set or organization, like developers and operations. So it's encouraged to have this kind of open exchange. It's encouraged to have participation, so having people with different skills, like developers, participating into processes which are not proper of their own skill set, like into operating a system into production. So participating cross-boundary, cross-different silos. The idea of rapidly prototyping and rapidly releasing things into production. The idea of meritocracy, so basically building communities around the skills and the way of working of each other. All of those values, which are, I would say, non-technical skills, but are soft skills and values of the open source, are not related to a particular technologies, are a set of values and a set of way of thinking, a set of points that are common between DevOps and open source. And for such a reason, you can see that a lot of components that are commonly used for doing DevOps and microservices are open source. What you are seeing right now is the Cloud Native Computing Foundation landscape. It's enough if you look into a search engine, you search for CNCF, which is Cloud Native Computing Foundation, you will find this landscape, this map. This map is basically a map that make a summary of different things for creating cloud native and microservice application. And a lot of pieces that you see in there are basically open source projects. You can find Kubernetes, you will find Docker, you will find Ansible, a lot of Jenkins itself. You will find a lot of projects and libraries. There are many commercial vendors behind such projects and such libraries, but you can also find a lot of open source version of such libraries. So basically, open source is crucial for the development of cloud native and microservice application, and is crucial for developing tools for supporting DevOps processes. And for this reason, I would say that open source, it's a fundamental ingredient of DevOps and of microservices. It would probably be impossible to have DevOps and microservices without open source, even because open source is also a way to ensure open standards, and so to ensure that the microservice that you will build using a software stack, it will be easily movable into a different software stack or hardware vendor or things like that, which it will bring us to Hacktoberfest. I think that everybody here knows what Hacktoberfest is. 2021, everybody is encouraged to find a project and start cooperating with a project, or starting sending some code or some fixes to the project that they prefer. With that link, you can start exploring different projects belonging to Hacktoberfest, so it's easier to find a project that you can like and you can start to contribute to. For this particular speech, I was in touch with a team inside Red Hat that is taking care of a project. This project is called Cryostat, is participating to Hacktoberfest. I've shared this with the project maintainers, and it's basically a way to collect statistics and metrics from Java application in a Kubernetes native way. It's just like an example. Of course, you can find a lot of other interesting projects if you want to, but if you want a project to start from, I strongly advise you this Cryostat community, which is building what is called flight recorder, so a way to record metrics and important statistics from the JDK, and in doing this in a Kubernetes way. So if you look into the website or into the GitHub repo, you will find that this project is composed by many different modules, like there is a user interface, there is a collector of metrics and similar stuff. And I think it's a good way to start contributing. If you don't have any particular idea on where to start, it is a small repo. There are no many people contributing. There are no many projects, so it's very easy to start developing with. Just start having a look. It's written mostly in Java, and you can also reach out the community over that Google group. So just writing an email if you want to some ideas on how to start, or you can just go into the project and start looking for bugs or for feature requests and start getting into the project and cooperating with the rest of the community. With this, I'm at the end of my speech. You can find my personal information, my email address, and you can write me directly if you need any further support. I hope you found this speech interesting, and if you have any further question, I'm here. Reach me out directly now or via email or via any other channel that you like.
Well, thank you so much for the presentation, sir. It was very informative. I definitely got a good understanding of what DevOps and microservices is about. And I'm pretty sure many people from the audience that are present with us today are also very much intrigued by the presentation and definitely want to delve deeper into various DevOps technologies out there. So now moving on to the Q&A session, we've picked up a couple of questions. So for the first question, we want to know, how did you get started with DevOps and microservices, and what has been your motive behind getting into DevOps?
So it was not something that happened overnight. So basically, I started working with Java software many years ago, and starting working with DevOps and microservices is not something that happened overnight. If I have to say one important step was when my customers and generally the community started using Kubernetes. Kubernetes and containers were a strong accelerator into the whole concept of DevOps and microservices, because everybody started understanding that it was an interesting piece of technology that can open some interesting use cases. But as I said during the presentation, in order to use containers and to microservices and to use technologies like Kubernetes, you start challenging the way you used to do things before, so the way you used to bring your teams together to work. And I can say that, yes, starting to work with Kubernetes and containers and microservices was basically the turning point. When such technologies start to become popular, I could say here in Italy, it was like 4 or 5 years ago, everybody started understanding that in order to use such technology in a good way, you also need to shift your way of working into a more agile way like DevOps did. So I would say that, yeah, that probably was the trigger into moving into this different way. At the very beginning, I suggest to, as I said, I suggest to read that book, which is very informational, like the Phoenix Project, but there are a lot of other interesting resources around, like a lot of articles into the ThoughtWorks and Martin Fowler blog that you can find around that are very, very informative. There are a lot of books now on DevOps. And then once you grasp like the basics of the DevOps methodology, you may start getting some deep dive information of pieces of technology that you may be interested in. Like Kubernetes is a standard from the infrastructure point of view, but you may be interested into having some more details about Spring Boot or I don't know, Ansible or things like that. So then you start deep diving into the technology. But I would suggest to start from the methodology as a broader things. And then when you start working at a particular project that is using some particular technology, then shifting into that specific technology. But technology is just one piece of the whole picture. The most important piece is understanding the methodology and the principle as a whole.
Oh, well, thank you so much, sir. That was very well answered, and we'll definitely check all the resources and books that you have mentioned. And moving on to the next question, Karthik, would you like to take up the second question?
Yeah, again, viewers, thank you for contributing your questions and concerns during registration. I have taken the most often cited questions here. I will be posing them to our keynote speaker, Mr. Giuseppe. So the question is, in what ways can we factor security into your DevOps process?
That's a very, very good question. So at the very beginning, security was a challenge into DevOps world, because releasing more often and having more pieces of software to release, it was not something that was factored into the standard security processes. So basically, it was very challenging. I remember that when I started, especially with banks, we did a lot of such communities and microservices building, but then everything was like stuck into security checks because basically also the security model was expecting to have like an inspection of the code at the end of the development process and similar things. So what is happening now is that a lot of people is talking about DevSecOps, which means basically having security experts together with the rest of the team. And another important concept is what is called shifting left security, which means basically embedding security concept at the very beginning of the software development process. In this way, you will end up having security testing doing things like code review in order to understand how the code works, and maybe in some cases they can also suggest best practices in order to embed security from the very beginning. So not waiting to have like security checks at the end when your code is ready and you can run tests against it, but starting with embedding security concept from the application design. Another interesting things into the whole DevOps concept is that you may end up having security tests automated into the development pipeline. This means that basically you can run the security tests like, I don't know, penetration tests and things like that every time you release your software. And so you will increase the security of each piece of software. This is opposed as the traditional way of having security, which is basically by steps. And so you will end up having a security check only at the end of the software development process when a release is ready, and then you will start concerning about security. This is considered to be the old way to do security. The new way to do security is to embed the concept of security in every step of software development lifecycle. So you will end up having penetration tests also at the end, but you will end up having a look at your code from a security perspective from the beginning and designing your architecture, taking care of the security aspects and running small pieces of security tests at every run of your deployment pipeline. So basically, the answer for having security into DevOps is embedding security into each step and embedding security expert into the team.
All right, then moving on to the next question. So, sir, can you give examples of processes that you usually automate when you're working on projects at Red Hat? And can you tell us about a process that was a real challenge for you to automate?
That's a very good question. So in theory, as we said when talking about Phoenix versus Snowflakes, you are supposed to automate everything. So basically, every aspect that it's an iterative process. So you will end up having releases into production or having new projects starting. And as long as you start working with that project, every time you find yourself doing something manually, you are supposed to understand if there is a way to automate such process. The first thing to do, at least historically, it's automating everything which is related to source code. So things like, of course, building the source code, running the unit tests, branching the code into the source code repository like in Git, or I don't know, generating the documentation for each release. All these kind of steps are usually easy to automate, and is the starting step, like everything into the building pipeline, the continuous deployment, I would say, pipeline. So the first part of such pipeline, so everything which is related to the compile of the source code, to preparing the artifacts, to versioning such artifacts, versioning the source code. This is the first part, and is what to start with. Then, of course, you will have all the other things that are related into the delivery process, which are like building the environment, building the right configuration, scaling the environment, running performance tests. All these kind of things are usually the second step. They are now easier to automate because you can use tools like Terraform, Ansible, Puppet, stuff like, or even Bash script if you want to do it in a bit more old style way. So this is the second part, that it's usually a less, especially if you come from a development mindset, they are a bit less easy to automate. As of today, this second part, automating all around the infrastructure, like, I don't know, network and stuff like that, it's a bit easier because you can find cloud providers that basically are providing APIs for everything. If you look into Google, AWS, Microsoft Azure, whatever it is, each of those, they have APIs with which you can provision everything your application will need. So you can order, I don't know, a database, you can order a network appliance, you can order a storage system, stuff like that, simply by calling an API. So basically, this is a good way to close the loop and having everything being automated into your life cycle. But this second aspect is also the hardest one, especially if you are not running into public cloud. So basically, if you are manually using hardware servers into your own data center, in order to achieve such degrees of automation, there are a lot of steps before, like you will need to create what is called a private cloud and operate against it. So this is the last easy aspects to automate. Another important thing to take into account is that even if you are left with basically everything automated from a technical standpoint, if you are operating into an environment which is an enterprise environment, very often there are still some manual things to do, like basically a manual approval for production. It's very common in some customers of mine that from a technical standpoint, you are ready to have everything automated and you can just click a button and having your application goes from source code to production. But still, because of internal regulations or maybe also low regulations, you will need to have manual approval for some steps, like, I don't know, for changing to the production database or for creating new tables or things like that, or simply for doing the release. So this is also another important aspect. You may end up having everything automated from a technical standpoint, but still having to do some manual steps in terms of having the permission for running some particular things, especially against the production environment, or when you're releasing something that is going to consume a lot of resources, maybe you will need to have somebody manually approve this step. So I would say that from a technical standpoint, as of today, especially if you are moving into highly technological environments like cloud provider, almost everything is easy to automate. So it's hard to find something that is not easy to automate as of today, especially if you are running into newer environments. It's more challenging if you are if you are playing with older environments like legacy hardware, stuff like that, which may not be so easy to automate. This is particularly true in some banking environments which are running some legacy system on legacy hardware that doesn't provide APIs. And as I said, another challenge is that you may end up having everything automated as well, but still needing some manual approvals from a regulation point of view.
Well, thank you so much for the answer, sir.
Mr. Giuseppe, I'd like to ask you a question.
Sure.
What are your favorite DevOps tools? What makes them great in your opinion?
That's a very good question. So when I started, I would say that probably the most essential tool for starting with DevOps was Jenkins. Because wait for defining pipelines, doing and triggering whatever you want. So you are able to find plugins for Jenkins doing whatever you need, from compiling Java code to versioning software to creating documentation to running tests, whatever you like. So this used to be like a standard tool, and it's still one very interesting tool. Since a couple of years, I'm looking into alternative tools in order to overcome some limitation of Jenkins. The most important limitation of Jenkins is that it's a monolithic software. So it's old-fashioned client-server software, which is basically a big process. It will need its own database. It's not so cloud native, if you want, as a tool. It's a big tool. So it works very well. It enables you to create DevOps and pipeline processes, but in itself is not easy to manage because it's a big server. It requires a lot of resources. It's not supposed to be run containerized. You can run it containerized, but it was not born as a containerized application. So it has some technical challenges, if you want, while still being a very good tool. As of today, I'm looking into some other tools. One interesting one, which I'm looking after, is called Tekton. You will find it into that map that I've shared into my slides, so the CNCF landscape map. But if you look after Tekton project, you will find a lot. And it's basically a way to provide features similar to the ones that Jenkins produced. So pipelines and structured ways of building software and compiling, whatever it is. But it's a tool which was born to be native for Kubernetes. So basically each step of a pipeline, so the step for compiling, for testing, whatever it is run on its own container. And in this way, you can easily customize every step because it's enough to create a container for that particular step, and Tekton can run it. And it's also particularly keen on resource usage because being everything a container, it can bring everything down if you don't need it. So basically, it doesn't consume resource when it's not needed to consume resource. So this from the CI/CD and pipeline point of view. Of course, there are a lot of other tools which can be used for implementing DevOps processes. I just want to mention other two tools which I like a lot. Well, I would say three. So one tool, as I said, is Kubernetes, because basically it's not particularly related to DevOps. So basically you can use Kubernetes even if you are developing not in a DevOps way. So it's not specific to the DevOps methodology, but it's a very nice supporting tool because it provides you a lot of features, like you can do self-service, you can spin up containers easily. It will provide you with a standard infrastructure, so everything running on Kubernetes may run on a public cloud provider. So it's a nice tool. I strongly advise you, especially if you are doing microservices. Another tool is Ansible. I mentioned many times, so a way of scripting and automating almost everything. So you can write what Ansible call a playbook, which is basically a lot of steps doing different things and scripting, and everything will be versioned into a text file, which can be stored into your source code repository along with your source code. So basically, it's a nice tool. Last but not least, shifting on a more development point of view, everybody doing microservices as of today, if they are using Java, they are often using Spring Boot, which is a great tool for creating applications in no time. So basically it gives you a head start when you are starting development with Java. But I want to mention also an alternative to Spring Boot, which is called Quarkus, which is another Java library, very nice for creating microservices. And compared to Spring Boot, it has more or less the same features. It's supposed to be faster, to use less resources. So I want to suggest to have a look at both Spring Boot and Quarkus as two libraries for creating Java microservices, for creating things that can be easily containerized and run into a microservice environment.
I really appreciate, sir, and it's a very good answer. So Bhargavi, you're good to go.
Yeah, sir. So as you have mentioned about waterfall model and agile development in one of your slides, so
Yeah.
so both of them were used before DevOps was introduced. So I wanted to ask if projects where requirements, are at a very low risk of changing, so which doesn't involve a lot of iteration. So do you think that we can still carry out such projects using the waterfall model without using any of the DevOps technologies? Or do you think it'll be better if we just include DevOps technologies even when we are dealing with projects of that sort?
That's a very good question, and honestly, there is no perfect answer to that. So I do have another speech that we can have another time if you want to, which is basically around just the development methodologies. I would say that there are still some projects that are unable to use DevOps technologies because of regulation, because of the way they are designed from the beginning because of the particular industry in which you are running. I would like to make an example here. If you look at the software development process as generic product creation process, there are some products that are impossible to be made with a DevOps-like methodology, or at least that are very hard to be made with a DevOps-like methodology. A common example here is airplanes. Airplanes, they will need a very structured way of working. You will need to order all this part, and then you will need to do this kind of test. And if you change something, you have to start from the beginning. It's not very easy to use an iterative and agile methodology like DevOps for doing things like building a plane, because it's a very structured process, it's very expensive. So there are some very structured steps, and it's better to start with this basically straight through methodology, this waterfall methodology into building things like an airplanes. What I want to say with that, I want to say that even if you are into a project that is mandated by, I don't know, the law or by some regulation or by some internal decision to use waterfall, you may still end up using some pieces of the things we are mentioning here. So of course, if you are building microservices and you are using DevOps, maybe you will end up using 100% of Kubernetes features or 100% of your cloud provider features. That would be the better way for using some tools. But still, if you are doing waterfall and you end up having your infrastructure being automated with something like Ansible, or you will end up having your test automated for every release using something like Jenkins or Tekton, you will still have some benefits. Then, of course, if you want to achieve like the most benefits from those technology, probably using DevOps and microservices is the best way for getting the most. But still, I think that there are some best practices, like having the customer being part of the team, like having the dev being at least aware of what the ops are doing, which can be beneficial even if you cannot use the whole DevOps story. I don't know if this answers your question. It was a very interesting question, but I think that it will need a very complex answer.
It's a very good answer, sir. Looks like we answered all your questions, viewers. Mr. Giuseppe, is there anything else you would like to mention?
Nothing particular. I just want to thank you for inviting me. It was a pleasure to be here, and I hope we can do more of this in the future.
Thank you, sir.
Thank you so much for answering all the questions in such detail, sir, and really appreciate all the knowledge regarding DevOps that you have shared with us today. And I'm pretty sure everyone in the audience got a really good overview of DevOps and microservices. And on behalf of everyone at OSC and everyone in the audience, I want to thank you for joining us today and giving us such an amazing presentation.
Thank you. So don't hesitate to reach me out if you need any further support or if you have any further question.
Yes, I definitely will do that. And yeah, we'll be having a quiz. Oh, sorry, sir. Go ahead. Yeah.
No problem. Go ahead.
And we'll be having a quiz very shortly, and the questions will be around the topics discussed in this session, so around DevOps. So make sure you attend that, and following that, Vijay will be discussing about the repositories that we've mentioned earlier, so that you can contribute to as a start to Hacktoberfest. So you don't want to miss out on that. So yeah, we'll see you shortly. Yeah.
All right, guys, like now let's get on with the quiz, and you can see on your screen the code for the quiz. I will be posting the link on the chat box soon. I guess the quiz link has been updated in your chat section. And yep, you can join, and we'll be starting with the quiz shortly. All right, 4 have already joined. Let's see. And before we move on, let me just say it out right now. The top 3 participants of the quiz will be getting some swags and certificates, and we will be noting down their names, and they will receive a mail regarding this soon. Okay, 15 students, 15 attendees, should I say, not students, have joined so far. Let's see. 16. All right, we got some funky names here. All right, if you haven't joined, do check it out. Join as fast as you can. We'll be starting in about 120 seconds, 2 minutes. All right. Still, if there's anyone to join, yep, you can let me know. If the link is not working, please do let us know. You can reach out to our team in the chat section. Like, you can reach out to the Q&A or the Discord as well. So yep, I guess that's it. Then here we go. Let's start the quiz. All right. All right. Yeah. So all right. Code Queen is in the lead, followed by Darth Coder and Aditya, and Bonocore is also there. Darth Coder is the lead. Right. Second, right. Still a long way to go. Anyone's game is this, and Code King has come out from nowhere to take the lead. Wow. All right. Let's see. Right, Code King is now a streak of 3 answers. All right. And Dark Code lead just 10 minutes. All right. Right. And now Code King takes back his lead. Was done before this, and he's looking to secure that dub. All right, Batman's coming up. And now just first 4, I guess. And now let's see. All right, Batman has done positions, I guess, say a couple of positions to third place, the podium. Okay, Code King is still in the lead. No, it's Darth Vader who takes the lead at the dying of the quiz. And some Venkatasadu who takes podium right now. As it's Aditya who takes the podium. Let's see. All right. What has come from out of nowhere? Top three. You know, it's Venkatasadu fighting for the team spot. Batman comes. Anvita who takes second. And it's Manvita who takes the lead at the last kick. And we need to go. And Sai has come in to take third place. Can he hold on? Is the question. Let's see. Yeah. So as of now, it's Manvita who stays first. Dark third, beating the top two, and Sai will be the top. And still got some other people to finish up. It's like God is still there. And we got Tarni, who's 13, and she goes to place. So right, still the quiz hasn't been over yet. Wow. All right, we will be ending the quiz shortly in about a minute. So if you haven't, wrap it up as soon as you can. And we will be ending shortly in about 30 seconds. Going nice. And all right, that would be the end of the quiz. Let's see, at third we have Sai, second we have Darth Coder, and at first we have Mani. That's all of them, and all of them participated in this quiz. So big ups to yourself. And yep, to the winners, we will be contacting you shortly. And I think Manvita, can you please send your registration number in the chat section? As well as I would say Batman. whoever this guy is with a funky name. Please do contact us in the Q&A section with your real name and your registration number. And yep, we would be good to go. And please do contact us if you're unable to contact us through this live Q&A. Please do contact us in the Discord server. You are there. You are welcome there. Our team will always be there for you. And yep, congrats to everyone. Congrats to the winners. Congrats to all the participants. Yep. And for those who didn't win, so no worries. There's still next time. We will be there again with some new speakers, a new event, and yep, another place, another time. And yep, that's about it. And I guess we'll wrap up the quiz right now. And yep, congrats to everyone.
All right. Thank you, Rahul, for hosting the quiz. It was pretty fun. So the quiz was pretty exciting and fun. And as mentioned earlier by Bhargavi, the event does come to an end now. But wait, are you looking to contribute to open source and win those sexy Hacktoberfest swags? We've got you covered. I'll take you through a few of our open source repositories here. Okay, so can someone just unmute and tell me if my screen is visible?
Yep, it's visible.
Okay, so this is our open source community's GitHub organization page. You can find it at github.com/open source community VIT-AP. So once you go there, you can find that we've got plenty of repositories, and it's got its own contents and stuff. So firstly, for people who do not know how to get started, for contributing to open source community, you can just log in, create an account on GitHub, and here you can search for Hacktoberfest. And then you can click on all GitHub. Here you can find all the tags that are mentioned with Hacktoberfest name, right? So if you come here, you can select the language that you're interested in. So if you want to code for JavaScript, Python, HTML, any of the languages you're interested in, you can even click on advanced search and search for the languages you're interested in. So let's say I select Python. You can go through, there are around 9,200 repositories, right? So you can choose any of the repositories that you want to contribute to. So suppose we can go to this page, we've got these, various different repositories. You can, open any of these repositories, find out issues, or find out what they are working on, read through the documentation pages, and you can contribute to those repositories, which will get counted for your 4 pull requests. Now, apart from that, we from open source community have also taken, the time to allow you to contribute to our own repositories. So if you go, we've got 2 different repositories set up for you guys right now. So we've got OEC Hub as well as Productivity Tracker. So if you go to any of these repositories under our organization, you can click on issues and you can find these Hacktoberfest tags, right? So you can click on these issues and find out there are these various different issues. You can go through these. We've got documentations as well for all these projects. You can read through them and contribute, send in pull requests. Or if you think there's any feature that you want to add by yourself, you can go ahead, create an issue, and if a maintainer approves the issue, you can start working on the project. All right. So next up, we've got right. So just give me one second. So these are the 2 things. But if you're a fresher and if you're not sure how to actually start contributing to open source, if you don't know how to send in a pull request, worry not. We've got you covered. So the moment you open our organization page, you can find Open Source 101 repository. So click on that. Here we've got step-by-step procedure, starting from prerequisites on to every single step that you'll be going through in order for you to actually send in a pull request. You can read through all the different steps and send in a pull request. However, this contribution made to this repository will not be counted towards your pull requests for Hacktoberfest. This repository is only for you to learn the basics of how you can get started and send in pull requests. Once you do successfully send in a pull request, your ID, name, and everything will get reflected onto this page. So considering that today our speaker explained and spoke about DevOps, we've implemented a few concepts of DevOps for continuous delivery, CI, and all that. So we've used GitHub Actions for doing that. You can actually go through the source code. You can click on websites, go through the source code. I can click on .github and go through workflows to see how we actually implemented the workflows and how your pull request is being reflected onto this website. So if you actually send in a pull request to this repository, your name, ID, and your GitHub profile picture will be updated onto this page. You can test it out. You can learn more about DevOps. You can learn more about contributing to open source, and a lot more by just simply contributing to this repository. So yeah, that's pretty much all that we've come up with for this session. And yeah, that being said, before we leave, so before I end this session, I actually have a sneak peek for you guys. We've got another Hacktoberfest Special event aligned 10th this month. Okay, it's again a collaborative event with women in open source. So this will be an open source talks episode 2 Hacktoberfest Special. So don't forget to tune in for that. And that's it from our side. Thank you all for joining us today. You guys can leave. Thank you. Have a good day. If you guys have any queries, you can drop them in on our Discord server. Yep. Thank you guys.